To all, the topic of my lecture is Special Glasses Part 1. The first special glass which we will study is optical glass. Optical glass includes only those glasses with high homogeneity and special composition, which have definite optical characteristics of such accuracy as to permit their use in scientific instruments. The important requirements of an optical glass are as follows. Its composition should be according to the required optical properties. The batch material used should produce glass of low viscosity. The glass should not devitrify. It should produce nearly a colorless product without the use of coloring material. The glass should be free from bubbles. The glass should have advantageous grinding and polishing properties. It should be capable of withstanding the action of atmosphere. Optical glass is also known as Crookes glass. It generally contains phosphorus and lead silicate with little cerium oxide. Cerium oxide is capable of absorbing ultraviolet light. In general, optical glasses are relatively soft and have low melting points. Optical glass is used in making lenses of microscopes, telescopes, etc. The next type of special glass is borosilicate glass. This glass is an example of optical glass and contains 13 to 28% of B2O3 and 80 to 87% of silica. It has low expansion coefficients. It has superior resistance to shock. It has high electrical resistance and high chemical stability. The composition of a typical borosilicate glass is SiO2 80.5%, B2O3 13%, Al2O3 3%, K2O 3%, Na2O 0.5%. A glass of low thermal coefficient of expansion and high chemical resistance is obtained by substitution of alkali and basic alkaline earth oxides of the soda lime glass by boron and aluminum oxides. These glasses are used in the manufacture of baking dishes, laboratory glassware, pipelines, insulators, and washers. Another special type of glass is the lead glass. Lead glass is obtained by mixing lead oxide, silica, and alkali with lead content as high as 92%. The important properties of lead glass are it has high refractive index, low hardness, it has a high dispersion power, it has high density. The density of high lead glasses can be as high as 8. They are widely used in optical work because of their high index refraction and high dispersion. They are also used in the manufacture of electric bulbs, neon tubing, and radiators because of high electric resistance of glass. The next special type of glass is glass wool. Glass wool is obtained by the action of steam jets on dripping streams of molten glass down from small holes. The glass wool, which consists of innumerable tiny fine fibers formed in this manner, is carried away by a conveyor belt on which it is hurled. Glass wool is a fibrous wool-like material composed of intermingled fine threads of filaments of glass and has a number of important properties. It is non-combustible in nature, it is fireproof, it has low electrical conductivity, it is heat-proof, it does not absorb moisture or water. Glass wool is chemically resistant to a number of chemicals. Glass wool has a low density of 65 kg per cubic meter. It has low thermal conductivity. It has a high tensile strength, about 8 times that of steel. Glass wool is used for heat insulation purposes in ovens, metal pipelines, motors, vacuum cleaners, walls and roofs of houses, and in domestic appliances. It is also used in the filtration of corrosive liquids such as acids and alkalis because it is chemically resistant. It is also used for sound insulation and for the manufacture of fiberglass by blending with plastic resins. Next type of important special glass is photosensitive glass. This is high alumina soda lime glass which is sensitive in UV region. It can reproduce the light. It can reproduce the object in live natural colors from an ordinary black and white negative recorded in the visible region. The positive on glass is developed by thermal treatment at 540 degrees centigrade to 550 degrees centigrade. The desired photo in ultraviolet region can be obtained by administrating a mixture of high alumina soda lime glass with small amounts of Cu2O, NaCN, SnO2 in appropriate amounts. A blue color is promoted by NaCN in absence of tin oxide. In presence of tin oxide, an impression in red is obtained. A potash alumina glass mixed with LiSiO3, cerium and silver salts in appropriate proportions have also been used as photosensitive glass. The next type of special glass is photochromatic glass. Such glasses have a large number of microscopic particles of silver halides trapped in three-dimensional silicate network in fixed concentration. On exposure to light, temporary color centers consisting of silver particles silver particles only are produced, and these add up quickly, producing total darkness. The intensity of darkness depends upon the concentration of silver, because reversible darkening is controlled by radiations in the ultraviolet region, quite abundant in daylight. The photo blackening does not occur markedly in the lamplight at night. Thank you.